So in this next section on the top of page 116, we are asked to determine whether each of the following differential equations are separable. And we're only going to solve separable DIffEQs in this class. So for differential equations to be separable, that means that we must have a product of x's and y's, because it's going to be through like division that we'll be able to separate x from y. So if we were to scroll back for just a second through these other examples, in the top example, the differential equation that we worked with, these are all separable. So we had dy dx equals x times y. In that second one, we had y squared times the difference x minus y. So again, we can think of those as two factors. So for these, we want to examine which of these are in fact factors, which are written as multiplication. So for the first one, maybe it jumps out to you. The first one is out. The first one is not separable. And if we kind of think it through, if I were to multiply both sides by dx, we'd be left with dy equals x plus y in parentheses, that whole thing times dx. And we could distribute the dx if we wanted to, x dx plus y dx, but there will not be a way that we could possibly get the y by itself or get the y to the dy side without taking a dx with it. So this one is a no. It is not separable. For the middle one, it maybe jumps out to us as a more obvious yes. So we could write our factors that involve x together. So I could think of this as like x times e to the x squared times y. And when I multiply both sides by dx, I would be able to divide both sides by y, and all of my x's would be on the right and all of my y's on the left. The last one's maybe, the middle one's a yes. That wasn't clear. The last equation is maybe a little less straightforward. The first thing that I would do is I would get y prime by itself. So we could do that by adding the term xy to the other side. And if you want, you could divide by 2. So y prime is going to be, I'm going to add the xy to the other side. I guess I should write the 2 with it the first time. So 2y prime equals xy. Therefore, y prime, aka dy dx, is xy over 2, or 1/2 x times y. So if I rewrite that, dy dx equals 1/2 xy. I can see that now the right side of my differential equation is a product of x and y's, and 1/2. So if I multiply my dx to the right side, I could again divide both sides by y. So we'd have 1 over y dy equals 1/2 x dx. So yes, that third one is also separable. All right, we're gonna work out a couple more examples. In this next video, again, I'd really encourage you to try this one on your own. Pause the video as you need to. I'm gonna start off with that first step we said is to separate. And in order to separate this one, we're actually going to need to factor on the right side so that we can get the y by itself. So pause the video and take a moment and see if you can separate dy dx. All right, so as we separate this, again, I'm going to rewrite this. I'm going to multiply both sides by dx first. So x times y squared plus 9x. I'm not going to factor yet. All right, once we multiply dx to the other side, we would now need to factor out our GCF, or really anything, just so that we're left with x's and y's in factored form. So in this case, it is our GCF. If I factor out an x, I'm left with y squared plus 9, all of that times dx. And then the last step to separating is to keep the x with the dx, but to divide both sides by the factor y squared plus 9. So I'm going to write this as 1 over y squared plus 9 times dy, and that's going to equal x times dx. So that's our first step of separate. We know the second step is to integrate, separate, then integrate. So take a moment, pause the video, and try this integration step by yourself. All right, so in step 2, when we go to integrate, we're integrating both sides. On the left side, this is something we learned in chapter 7, so hopefully some of those formulas are fresh in our mind. This is not something we could do a u sub with. If you think about it, for a u sub, we'd need a linear y term somewhere in our function, which we don't have. So this is actually arctan. And remember, this is one of those antiderivatives where we've got to almost think of it as like an a substitution. So because that 9 is not a 1, I might even rewrite that as 3 squared. And this is all from unit 7. Hopefully we have not forgotten unit 7. And if we have, all that information's in the back of the spiral on page 117, as well as the unit 7 pages. All right, so if we recall, when we have the a value that's not 1 for arctan, it's going to be 1 over a, so 1/3, because a squared is 9, times the arctan of, it's going to be y instead of x, y over 3. So that's the left side of the equation. The right side is just 1/2 x squared plus c. All right, so that is the integration step. After we separate and then integrate, we have 2 things to do, and we could try them in either order. So we can either plug in our initial condition 2, 0 and solve for c, or we could solve for y and then find the initial condition. Again, I would recommend you usually try solving for c first. So let's take a moment. Please pause the video and try to solve this one for c. All right, I'm gonna go ahead. So as we solve for c, we're gonna plug in 2 for x and 0 for y. So 1/3 times the arctangent of 0 over 3 equals 1/2 times 2 squared plus c. All right, so when we are thinking about, actually the first thing I would do before even considering the arctangent is I would get rid of that 1/3. So let's just multiply, by 3. No, actually, I take it back. Let's not. You can if you want. I don't think it's actually going to make this any easier. So here's why. Because the when we think of what is the arctangent of 0, right? Because 0 over 3 is just 0. What I'm really thinking about is in radians, the tangent of what number and what angle in radians between negative pi over 2 and pi over 2, the tangent of what is 0. So if we think about that, from negative pi over 2 to pi over 2, I'm going to just sketch this up here. If we just think of our unit circle, here's negative pi over 2 at the bottom, positive pi over 2 at the top. If I think, all right, when's the tangent 0? Well, tangent sine over cosine. So the tangent will be 0 when the sine is 0, which happens at 0 radians. So the reason I changed my mind about multiplying by 3 on both sides is it's just going to be 1/3 times 0, which seems easy enough to do on our own. All right, so we get 0 on the left side because the arctangent of 0 is 0, and 1/3 times 0 is 0. And that equals 2 plus c. So subtract both sides by 2. We get that c is equal to -2. But we've got to plug it in. We've got to plug that in before we solve for y. So let's rewrite this as 1/3 times the arctangent of y over 3 plus 1/2 x squared, either plus -2 or just -2. All right, so since we solved for c first, we must now solve for y. So take a moment, pause the video, solve for y. I'm going to keep trucking. All right, number 4, or part 4, solving for y. This is where I would definitely, oh my goodness, that was supposed to be an equal sign. I just caught that. Sorry, that plus in that last statement is an equal sign. All right, this is where I would multiply both sides by 3. So to get rid of the 1/3 on the left with the arctan, so we have the arctangent of y over 3. If I multiply both sides by 3, it kills the 1/3 on the left. And now I have 3 times 1/2 x squared minus 2. So I would go ahead and distribute that 3, and I would rewrite that as the arctangent of y over 3. And when I distribute that, order of operations, 3 times 1/2 is just 3/2 times x squared minus 6. All right, so now we need the inverse operation of arctan to get rid of arctan, and the inverse of arctan is tangent. So we're going to take the tangent of both sides. Probably could have skipped writing it, but too late now. All right, the tangent of 3/2 x squared minus 6. All right, so tangent and arctangent undo each other. So now we're left with just y over 3 on the left, which again, to get rid of the division of 3, we need to multiply by 3. So we get y equals 3 times, because 3 is just, we're tripling the tangent, not the argument. So we won't be distributing that 3 to anything, but 3 times the tangent of 3/2 x squared minus 6. And that is our final answer. All right, the last example that's on here, I'd really like you to try it between videos. Try to work through the entire thing by yourself, and then watch the video real fast to check it.